So like I was saying, another toy that's similar in that vein is the shape sorter, where you have cubes or three-dimensional pieces of shapes that are supposed to go into a slot. But let's look at this toy here. So he's putting him into the right place. Interesting choice. Things aren't going the right. I'm pretty sure this is not how you're supposed to use it, right? He's putting them all into the square hole. So, yeah, and I'll let them finish because I've watched this many times and the arch always gets me, right? It clearly goes in the right place. So the reason why I'm telling you this is because testing can often feel the same way. A lot of times you write your test, your coverage is green, everything is passing, and no bugs are getting through. But other times you write your test, the coverage is green and everything is fine, but bugs somehow are still going through your system. So, hi, my name is Jose Trigueros, like they said before, and today we'll be talking about property-based testing and how you can use it to generate tests to cover more ground. While this might not be a silver bullet, I do believe that this approach can help you increase your test suite's effectiveness and also even reduce the amount of tests you have to write. Before we get into it, let's go over some of the terms so that we're both on the same page. You may have heard of these terms before: unit, component, and end-to-end tests. But it's important to not look at property-based tests as another one of these. Instead, let me redefine this and talk about example-based tests. Unit, component, and end-to-end tests are all example-based tests where you provide your input, example input, and then you provide your example output, and you make some type of assertion to get that test to pass. Property-based tests help you generate many of these examples that you can then assert on. So they're just stamping them out. If I had to make to go back on this, you use the concept of generators to generate these tests. And once you find an example that does not work, you use the concept of shrinking. So if we had to look at an analogy, that artisan bread is like an example-based test. You create it as one of one, you handcrafted it. Whereas property-based tests, you are still making bread and you're making slight variations, but you're stamping them out looking very similar. So now that we define those two terms, let's look at example-based tests and look at some of the shortcomings with this approach. For this, let's look at our previous example of the shape sorter. Let's say I was the one designing this toy and I made it out to production. And I was the one designing the function that tests whether or not a shape goes into a slot, and I'm also the one writing the test for this. So how do I go about this? We have our approach is to go with the happy path, where we know that a square can go into a square slot, and the unhappy path, which is a circle, should not go into a triangle slot. So if we were to write some code for this, what would that look like? So for the unhappy path and happy path, we both have about the same setup. We create a game instance. We define our shape and our slot. On the happy path, we have a square and a square. And our unhappy path, we have a circle and then a triangle. We run the function, capture the output, and then make the assertion. So for the happy path, we expect the result to be true. And for the unhappy path, we expect it to be false. And they both pass. Our coverage has to be at least 90%, and we have green tests, right? So what do we do next? We ship it to production, and we give it to our testers, paying customers, and they discover that, indeed, the circle goes into the square slot. So what happens then, right? They make a report, it goes to customer support, the customer support eventually bubbles up to PM, and then finally back to me as a developer. So then I go and write a test for this case, and sure enough, it does fail. So I create a patch, fix it, now the tests are green, and this is fine. We ship the next revision, and the customers are happy. And frankly, this is probably fine. We all do it. I do it. but you can hopefully now start to see the limitations. And it wouldn't be a good use of our time to write a test for every single iteration, right? And then, let alone they want a new shape, now we have to write another test or another set of tests that we have to write. So how can we improve this? With property-based tests, like I said before, you generate examples. Let me pivot a little bit to a more realistic example that is something that you may have done before. This is a wireframe of a form for a website, a subscription for a gym website that has an input for a name, email, and a subscription length. You are in charge of writing the backend for this and storing the results into a database. Don't get excited, it's not a real gym. It's a made-up example. So the data flow for this architecture might look something like this, where it looks exactly like this, right? You have the issue, the user provides the input, their name and email. They select something from the dropdown. They submit this to the backend. The backend takes it, the controller takes it, puts it in the database confirms, and then back it goes all the way up to the user. For this example, let's look only at the controller section. We're gonna be designing something for the business logic for this controller. I'm gonna be throwing some code at you, so before we go into this, I'm gonna just give you a quick primer on Clojure. So sorry for the deviation there, but Clojure is a Lisp. It's a hosted language, usually on the JVM or JavaScript, and it's dynamically typed. On the bottom here, you have an example of a function that you would see normally in an imperative language. So to convert this to a Lisp, you put the parentheses around the function, and now you have a list of symbols. Commas are optional, and it might have been a subtle change, but that underscore becomes a hyphen. Not strictly necessary, but it looks better. And the next data structure is a hash map. So here you have a key value, key value, key value. So I just wanted to show that this is a very common structure that we're going to be showing coming up. The controller, the business logic for this controller might look something like this. We have a function that processes the user data. It takes in the name, email, and duration. When we execute this function, we expect to receive back the ID of the record of the database. So you might call it with this type of input, where you have Alice, and Alice's email, and then some duration, and then the output is their ID. Here's another example. So one test we could design for this is a simple round-trip test, where we call this function with this input, and then we get the same output back once we query it from the database. If you squint, this could be the identity function, right? So here we wrote a simple test that tests exactly what I just talked about. But let's take it apart. On the top here, we have the example input that is provided: Alice, their email, and the duration. And the next section is the expected output. So I crafted that. I decided the name, I decided the email, I decided everything. And then I ran it through the through the function that I'm testing, the system under test, and I got the response back, and then I can make the assertion to make sure that it's good. On the previous slide, we saw that the test passed. And usually this is a good starting point for us to start writing a good property-based test. So now this is what it looks like to write a property-based test, and it's looking pretty similar, but let's go into the pieces again. So this 1,000 that showed up here, this is akin to the previous slide that had a bunch of examples. So you're telling the tool how many examples to generate for you. So in this case, we're saying 1,000, so it's going to run this 1,000 times. Instead of providing an exact value for name, email, and duration, you're going to be using generators, and those will provide you, I'm telling here to give me a string, an email generator, which I'll discuss shortly, and then an integer generator. And lastly, I call it generated result because I'm using the name, but it looks pretty much the same as the previous one example. So now let's go look at what generators are. So like I discussed before, we have a string generator and an integer generator. And this is provided by the tooling that allows us to do property-based tests. The sample function takes a string generator, and you call that when you want to see what is the generator going to give you. So this is the sample of something that you might get, and it is just a bunch of random strings. The integer generator gives you a bunch of random integers, and it's actually interesting that this is still passing with a negative subscription count. In addition to using the tooling's generators, you can create your own. And this is where the actual power comes here, because we know we need an email, but we can define how to generate an email. The top one, this is actually two generators. One of them is for domain, and the other one, which uses domain, is the email generator. The top one is simply saying that just give me one of those 3 domains. And then the next portion, I know it's a little terse, so let's focus on this specific part, which is just the output of the generator, which is going to be a name appended by @ and then the domain name. To look at what that looks like it's something like this. So we sample the email gen, and we get b5@computer.org, etc. So this is what the test would be consuming. Inside the generator implementation, there's a gauge that I like to think about it is of size. And this size is not, strictly speaking, the size of the output, but it's specific for each generator, and it's decided by the context of it. So here I just sampled out the integer with various sizes, 1, 10, and 1,000. And it might be doing some value between 0 and 1 or something. I didn't look at the implementation, but it's treated like a black box. And this is important because we use it for shrinking that we talked about earlier. So now let's run the property-based test, and let's see what we're getting here. So now we see that we run this test. Our example-based test passed, but when we run the property-based test, it no longer passes. I took the portion of the output and just put it on one slide so we can look at it more in detail. But this is the hash map that resulted back from running the property-based test. And here you get a lot of stats and values that you need to be able to reproduce the example that failed. So here we have the number of tests. So I asked the framework the tool to run it 1,000 times, but it only was able to get through 15 iterations before it had to fail, before it started failing. Here we have the example that failed. So there's 3 values in here. One would be the name, the email, and then the duration of the subscription. And lastly, we have the smallest example. So I was talking about shrinking in generators before, and it failed at the value below here. And once it gets to that point, it stops and it tries to reduce the size of each one of those generators until it gets to the smallest possible size to give you one that still fails. So this is important because in other times you might get really long strings, and maybe a really long string is not necessary. You might be able to get a failure with 3 characters, and then you can take this. So now with this smallest value found, we can go back and try to figure out what's going on. So using the smallest failed example, we are able now to call the process user data function. I just took the same arguments and put them in. And we can see that the function is still running. We get back an ID. So now we can check the database, what's going on over there. So we get the database value, database row, and we can see that we have name, email, duration. So I can just eyeball and see that email is matching, duration is matching, ID is matching. So name, I can't really easily see. So let's put it next side by side, and clear enough, it's not the same anymore. So now we have a hint as to where to go look. We go look at the source code, and we can see here at to do, I've done that, I forgot to do something. I know this is a contrived example, but it's the easiest way to show this. So this line is no longer needed. It's truncating the name by 10. So now when we put in a name that's longer than 10 characters that I didn't use on my own test, now the result is not the same. So now that once we fix that code and we run it again, now we get a passing test. So this completes the exercise of how you would go from an example test to writing a property-based test. And I would like you to make a mental note of that 217 milliseconds. We'll talk about that in a bit. So we applied this concept to the controller, but you could extend this to apply this to any part of the stack here. As long as you have an example-based test, you can also do the same to create a property-based test, but you do have to think about the domain and create your own generators. I do want to make this very clear that in order for this to be a property-based test, we do need shrinking and generators. If you don't have those two, it kind of does not make it worth it to go through the effort, because you're going to end up with a lot of random iterations and the values, and you won't be able to reproduce the failures. So it almost looks like it's an obvious step to take, but why don't we do this? Why is it, if you're here, you might have not heard of it before, and I don't see it in the field as often. So there are a few considerations to take that I've seen when I've used this in application. So one of them would be complexity. You need to consider the domain of your generators, like the previous example that we saw with email. You might have something else for your application. And if you don't have a good generator, you have to create it yourself, and that will define whether or not you're going to get good tests out of it. The next thing under complexity would be ramp-up time. It's very trivial to show a new developer how to write an example-based test, but it's not at all the same for this type of test. It's a lot more to think about and more to handle. And if you're writing, and remember, you're writing multiple iterations. So I once wrote a test where it was throwing an exception, and I wasn't sure what was going on. So it's a lot more difficult. So just like this guy right here, you have to contemplate and think about more as to what's going on. The other thing is time. I showed you the other test. It was a very simple round-trip test, and it took 200 milliseconds to complete the full 1,000 iterations. And sure, that's one test, but I bet your test suite is much larger than one test. So if you're writing thousands of these, it could start slowing down your CI pipeline. What I've seen done in the past is you split up in slow tests and fast tests that they run on different pipelines, but it's still something else that you have to take care of and people have to know about. And lastly is availability. I chose to use Clojure to give you an example of this because I've used it in the past and I know it works well. Scala is also supported very well, but in a lot of other languages, the tooling is less supported. But we still have a consolation prize. There's something called Faker. You may have used it or not, but it's not quite the same thing, but it does provide you a way to, this is a library that is available in Java, Ruby, Python, that gives you data that looks about real. And this might be a good substitute for the generated purpose. You're still writing an example, but you're not providing with the test case. You're not providing the data yourself. You're relying on Faker to give it to you. One caveat that I've heard from other coworkers say is that the data might be too nice, so it won't catch those edge cases that we saw with the previous generators. And that's closer to fuzz testing, where you're just giving it random things to see what happens. So but I would say this is still much better than putting in your own value. And you might say that this could lead to flaky tests, but I would rather have a flaky test that fails on random input than a flaky test that fails with changing nothing. So, but I like to end with this. Don't write your tests, generate them, because I don't want to write tests. Thank you so much for your time.